In 2016, in a museum in Cairo, a team of Italian and Egyptian scientists pointed an X-ray gun at a knife. They were not allowed to cut it. They were not allowed to scratch it, drill it, or move it more than necessary. The knife is one of the most famous objects on Earth. It came out of the tomb of King Tutankhamun, folded into the linen wrappings against the right thigh of his mummy, where it had been lying since roughly 1325 BC. The blade is iron, and that is a problem. Because when Tutankhamun died, nobody in Egypt could smelt iron. As far as the evidence shows, nobody in Egypt would smelt iron for another 7 centuries. The furnaces did not exist. The knowledge did not exist. And yet here was an iron blade, 3,300 years old, still smooth, barely rusted, buried with a king. The X-ray gun does one simple thing. It reads the chemical fingerprint of metal without touching it. The team fired, and the numbers came back. 11% nickel, 0.6% cobalt riding along with it. Iron made from ore, from rock dug out of the ground, almost never carries more than 4% nickel. 11% means the metal in that blade was never dug up at all. There is only one place it could have come from, and that place is not on this planet. So here is the real question. Forget who made the knife. Where does metal come from? In a world where no human being on Earth can make it. Start with the rock itself, because the rock does all the work of getting noticed. Say you are walking across open ground 5,000 years ago, and you find a lump about the size of your fist. You reach down and your arm gets a surprise. The thing weighs close to 3 times what a stone that size should weigh. It sits in your hand like a lie. So you test it the way you test everything. With another rock. A normal stone cracks. Flint shatters into flakes. This does neither. Where you hit it, there is a dent. The material gave way and then just stayed there, holding the new shape. You have never seen metal ore. You have no word for nickel. You do not know what a meteorite is. None of that matters, because the object is telling you everything you need to know. This thing does not behave like any rock in the world. And it is correct, because it is not from the world. The oldest iron objects human hands ever made prove that somebody figured this out very early. They are 9 small beads from 2 graves at a cemetery called Gerza in Egypt. And they are about 5,200 years old. Older than the pyramids, older than the pharaohs. In 2013, a team led by Thilo Rehren put the beads under modern analysis. And 2 things came out of that study. First, the metal was iron with nickel in it, meteorite iron. Second, and this is the better part, the analysis showed how the beads were made. Nobody melted anything. The maker took the metal and hammered it, over and over, thinning it out into a sheet, then rolled the sheet into a tube. That is jewelry work. Those are the hands of a smith who treats iron the way you treat gold. Because in that world, iron was rarer than gold. Some ancient price lists from the Near East value it many times higher. The Gerza beads were strung on necklaces right alongside gold and precious stones. And they had earned the spot. Whether the person who hammered those beads understood where the metal fell from, nobody can prove. What we do know is that the connection got made. And it stuck. Because centuries later, the Egyptians wrote it down. Their word for iron was bia on pet, metal of the sky. The people of Mesopotamia had their own version, a name that tied iron to the heavens the same way. Long before anyone could explain a meteorite, the civilizations hammering this stuff had decided it came from above. They were right. The most extreme version of this story sits in New York City right now, in Greenland, near Cape York. A group of iron meteorites fell out of the sky long ago. The largest weighs about 31 tons. For centuries, Inuit communities traveled to those masses and worked them like a quarry, hammering off small flakes in cold, working them into knife edges and harpoon tips. A culture with no furnaces and no smelting had iron tools, because the sky had handed over the raw material and skill did the rest. In 1897, the explorer Robert Peary hauled the biggest mass onto a ship and brought it to New York. It sits today in the American Museum of Natural History, and you can go stand next to it. It is the size of a car. It is so heavy that the museum could not simply put it on the floor. The supports holding it up punch down through the building and anchor into the bedrock of Manhattan itself. So humans had iron. They had it for thousands of years. What they had was a supply chain that depended entirely on rocks deciding to fall. And the cruel part is that the answer to their supply problem was everywhere. It was in the dirt under their feet. It was in the red and brown rocks they walked past every single day. Iron is one of the most common elements in the crust of the earth. They just could not get it out. Here is the joke the planet was playing on everybody. Those red rocks, the rusty brown streaks in cliffs, the dark heavy stones in certain hillsides. That color is iron. It is not a hint of iron or a trace of iron. Iron ore is basically iron that has already rusted. Every atom of metal in it is locked arm in arm with oxygen. And in some deposits, that grip has held for 2 billion years. The same metal is moving through your blood while you watch this. The iron was never hidden. It was imprisoned. And for thousands of years, nobody had the key. To see why, look at the people best positioned to find it. The copper smelters. By the time our story gets serious, copper working was already ancient. Whole regions ran on it. These were people with real furnaces, charcoal, bellows, generations of accumulated skill. They dug ore. They smelted it. They cast the results. Bronze, which is copper sharpened up with tin, was the best material human beings had ever made. And copper plays fair. Copper melts at around 1980 degrees Fahrenheit. And a good furnace with bellows can get there. So when a copper smelt works, the metal does the one thing everybody understands. It flows. It runs out as a liquid, glowing and unmistakable. And you pour it into a mold. The furnace gives you an answer you can see. Iron does not play fair. Pure iron melts at around 2,800 degrees Fahrenheit. Put those numbers side by side. The best furnaces of the ancient world, pushed as hard as human arms could push them, topped out somewhere around 2,200 degrees, 600 degrees short. That gap stayed open for thousands of years across most of the world. Furnaces that could actually pour liquid iron did not arrive until much closer to the modern era. So, melting iron the way you melt copper was simply off the table. Full stop. And this created a trap. And the trap is the most interesting thing in this chapter, because it lived inside people's heads. Every copper smelter alive had learned one rule from a lifetime at the furnace. Real metal flows. That is how you know it is metal. Whatever refuses to flow, whatever is left crusted in the bottom of the furnace, when the copper has run out, that is slag. That is waste. You break it up and you throw it on the pile. Now follow that rule to its conclusion. Sometimes, copper smelters used chunks of iron-rich rock in their furnaces as a flux, a helper material to make the copper ore behave, which means that on some days, in some furnaces, Small amounts of actual iron probably did form. Little gray lumps, stuck in the waste, refusing to melt. And the rule said those lumps were garbage. So into the pile they went. The very expertise that made these people brilliant at copper made them blind to iron. They may have made it and thrown it away, possibly for centuries. Now for the honest part. Nobody knows where or when the first successful iron smelt happened. There is no site anyone can point to and say, here, this furnace, this year. The leading idea is that iron making grew out of copper making, somewhere in or around Anatolia, in what is now Turkey, sometime past 2000 BC. But early iron shows up scattered across several regions. And there is a live argument about whether parts of Africa south of the Sahara worked out iron smelting entirely on their own. We cannot reconstruct the first smelt. Anyone who describes that moment to you in detail is telling you a story. What we can reconstruct is the machine they eventually built, because versions of it survived, and because people today have rebuilt it and run it. And here is the thing nobody standing at a copper furnace could have guessed. The furnace was never going to melt the iron. It did not need to. It needed to do something much stranger. Watch one smelt, start to finish. Because this is where the discovery actually lives. Furnace designs varied enormously from region to region and century to century. But one common version worked like this. The work begins days before there is any fire. Somebody has to make charcoal. And charcoal is expensive. Raw wood is useless for this job. Wood burns wet and dirty. And it cannot hold the heat where you need it. So you stack cut timber. Bury the stack under earth. Light it. And let it smolder for days with almost no air. Until what is left is nearly pure carbon. Cartloads of trees go in. Sacks of black brittle charcoal come out. The exchange rate is brutal. And you pay it before you have made anything at all. The ore gets its own preparation. You break the red rock down to pieces about the size of gravel, because the chemistry that is coming can only chew on what it can reach. The furnace itself is almost insultingly simple. A shaft of clay and earth, roughly chest high, open at the top, with a hole near the bottom for the air pipe. That is the whole machine. Everything that matters is invisible, and it happens inside. You light the charcoal, and then you feed the furnace in layers from the top. Charcoal, then ore, then charcoal, then ore, and you start pumping the bellows. Then you keep pumping, hours of it. If the air stops, the furnace cools and the smelt dies. So, someone's arms are the engine of this entire operation. People take turns. The furnace roars and spits sparks out of its mouth. And the layers inside slowly slump downward as the charcoal burns away underneath them. Here is what all that labor is actually doing. And it is stranger than melting. Charcoal burning in tight quarters. Starved of air. Gives off carbon monoxide. That molecule has a personality. It is hungry for oxygen. It will take oxygen from almost anything it touches. And packed in that furnace, flowing up through the hot gravel of crushed ore, it starts robbing the rock, atom by atom. It strips the oxygen away from the iron and carries it off as gas. Remember what iron ore is. It is rust. Ancient beyond counting. So look at what the furnace is really doing. It is running rust backward. Smelting was never about melting the rock. The fire steals the oxygen. And what is left behind? Still solid. Never once a liquid. Is metal. The iron never flows. Down near the bottom of the furnace. Freed from its oxygen, but hundreds of degrees short of melting. The particles of iron sinter together, sticking and welding into a single spongy mass, all of it tangled up with liquid slag from the rest of the rock. The slag melts and drains. The iron does not. It just sits there, in the dark, growing, and the person running the furnace can see none of it. There is no window. There is no thermometer. There is no way to pause and check. You read the color of the flame at the mouth. You listen. You go by feel and by memory of every smelt you have ever run. Too much ore in a layer, and you choke it. Too little air, and it dies quietly. Get the balance wrong anywhere along those hours, and you have spent your charcoal, your ore, and days of labor to make nothing. You find out whether any of it worked exactly once. At the end, when you break the furnace open. So break it open. You crack the clay. Rake out the coals. And look. And this is the moment the whole history of iron turns on. Because there is no bar of metal in there. Nothing gleams. Nothing flowed into a shape. What sits in the wreckage, glowing a dull red, is a lump. Gray. Warped. Full of holes, like a sponge turned to stone, with dirty slag oozing out of its pores. By every rule the Copper Age had taught the world, that thing is a failure. Metal flows, and this did not flow. Every instinct says rake it onto the waste pile with the rest of the slag. Somewhere, at some furnace nobody can name, somebody did the other thing. They pulled the lump out while it still glowed, laid it on a stone, and hit it with a hammer. Maybe that happened once. In one workshop. On one afternoon. Maybe it happened 100 times. In 100 places. Across generations of smelters, slowly getting curious about the strange gray lumps in their waste. The evidence cannot tell us. What the evidence can tell us is what the hammer found. A rock hit that hard cracks. This did not crack. It squeezed. The blow drove molten slag spitting out of the holes. And the sponge compressed under the hammer and held together. Hit it again, and more slag sprays out. And the lump gets a little smaller. A little denser. A little more solid. Heat it back up. Fold it. To hammer it again. Keep going through hours of this. And the ugly porous mass slowly consolidates into something with a surface, with an edge you could grind. With weight that answers the hammer honestly. A bar of iron. The furnace stole the oxygen. The hammer drove out everything the furnace left behind. Between the two of them, they pulled a metal out of a rock without ever melting it. And the people swinging the hammers had no idea that any of that was true. They could not see the carbon monoxide. They had no word for oxygen. They just knew the recipe. Because the recipe was the discovery. How did ancient humans discover iron in the ground? Someone hammered the lump that every rule said to throw away. And after all of that, the charcoal, the days of pumping, the hammering. The bar of iron in your hand comes with one more surprise. A good bronze blade was still better. Getting the metal out of the rock was only half the discovery. The other half took centuries longer. Because the metal that came out was not worth having yet. That sounds wrong. So here are the facts behind it. The iron coming out of those early furnaces was wildly inconsistent. Bloom iron that is close to pure is soft. Soft enough that a well-made bronze sword could hold its edge against it. And the smith had almost no control over which kind of bar a smelt would hand him. One batch forged into decent tools. The next came out soft, as a nail that bends on the first strike. The next was brittle and crumbled under the hammer. Same furnace. Same ore. Same people. Different results. And nobody could see why. Bronze had none of these problems. Bronze was a mature technology with 1,000 years of refinement behind it. It cast into complex shapes. It behaved the same way every time. And it took a polish that made it look like gold. Faced with a choice between the two, every serious buyer in the late Bronze Age chose bronze. Which brings up the story you may have heard. Because it sat in textbooks for most of a century. It says the Hittites, in what is now Turkey, invented ironworking, guarded it as a state secret, and conquered their neighbors with iron weapons until their empire fell and the secret escaped. The star witness was a letter from the Hittite king Hattusili III, replying to a foreign king who had asked for iron. Good iron was not available. The king wrote, "They will produce it, and when they have finished, I will send it. For now, please accept this single iron dagger blade." For decades, that letter was read as a monopolist protecting his trade secret. Read it again without the legend in your ear, and it sounds like something much more ordinary. It is a backorder notice. A king apologizing that the product is not in stock, and sending a sample to keep the customer happy. And the archaeology backs the plainer reading. Digs across the region have turned up no armories of Hittite iron weapons and no iron-equipped Hittite army. Iron objects from that era are scarce everywhere, scattered thinly inside the Hittite lands and outside them. In Egypt, in Cyprus, in Mesopotamia, there was no secret and there was no monopoly. For centuries, iron was a curiosity that trickled through royal courts as a novelty. Though bronze was better metal, what bronze was not was better logistics. Bronze has a weakness that has nothing to do with blades. It needs tin. And tin is geologically rare. A few significant sources fed the entire ancient world, some of them 1,000 miles or more from the cities doing the casting. At the far end of long trade routes, around 1200 BC, the trading world of the Eastern Mediterranean went into crisis. Cities burned, and those long routes broke down. The tin at the end of them stopped arriving. Iron ore, meanwhile, is in practically every hillside on Earth. Any community with red rock, trees for charcoal, and arms for the bellows could make its own metal and answer to nobody. When the supply chain snapped, the second-rate metal was the one still standing. Iron won on logistics. Then, at the anvil, it quietly stopped being second-rate. A bar of iron spends hours sitting in burning charcoal while a smith works it. And all that time, carbon is soaking into its surface. A fraction of a percent is enough to transform it. Smiths began noticing that some blades came out harder than others, without knowing why. And somewhere along the way came the next accident. Plunge a blade of that carbon-rich iron into water while it is hot, and it snaps into a state harder than any bronze ever cast. Analysts studying knives from Cyprus, made around 3,000 years ago, have found exactly that treatment. Carbon in the metal, hardened by the quench. The technique was young, and nobody controlled it perfectly yet. But it pointed straight at the material that would eventually get a name of its own. Steel. The smiths making it could not see the carbon and had no word for it. They held the whole process as craft, passed hand to hand through generations. Chemistry nobody could name and everybody could repeat. And it worked. Which brings the story back to a knife in Cairo. The dagger from Tutankhamun's tomb was never evidence that Egypt was ahead of its time. It was evidence of the first discovery. Sky metal, hammered cold by a jeweler's hands. So rare that it was buried against the thigh of a king, while common soldiers carried bronze. So how did ancient humans discover iron? Twice. The first time, they picked it up off the ground. Already metal. delivered from space. And they came to know it. Metal of the sky, the Egyptians wrote. And they were right. The second time took 2,000 more years. And it was not really the discovery of a metal at all. It was the discovery of a process nobody could watch and nobody could explain. A furnace that ran rust backward. A hammer that finished what the fire started. The iron was never hidden. It was locked. And the key was never a hotter flame. It was someone at a furnace nobody can name, deciding not to throw the ugly lump away.